Hello guys, how are you doing? In this video, we're going to learn about something called Mutation Observer. This is part of the JavaScript uh, core APIs, and this particular API takes care of, or it allows you to observe to DOM related changes that are happening within the time frame of your web page. You can make use of this and observe the changes that are happening to certain sections of the page and react to that by probably doing some business logic that would probably communicate with the backend or do some sort of validations, error validations in forms and such things. And it's pretty useful because generally DOM tends to be slower because of all the event handlers and the kinds of event listeners that happen for each and every interaction of the user with the browser, right? But Mutation Observer actually allows some slack or some sort of a relief from this kind of DOM intensive operations and gives us the ability to listen to changes without much browser performance being hindered or CPU usage getting heavy in such sense. So now let's see how this can be implemented, and then we'll see an example, and then we'll try to understand how this works. Now, this is the official developer Mozilla documentation page, and here you can see all about how the Mutation Observer works. And it says clearly that this is an interface that returns an observer, and it takes a specific callback, and whenever the DOM events occur. So this does not confine itself to any particular DOM event, but it rather listens to changes in the DOM structure itself based on how we ask it to do. And here's a quick example where the mutation observer is created using this constructor, signature, and then it takes a callback, and the callback looks like this, and the callback takes essentially two parameters. One is the list of mutations that happened, which is an array, and then the observer, which is the actual observer that we have passed this callback to. And then within this callback, you have access to each and every mutation, and each and every mutation here has a type. It can be childless mutation, or it can be attributes mutation, or it can also be child tree mutation or subtree mutation as well. And then here you can see that mutation.added nodes and removed nodes. These lists give us the kind of changes that happened, whether something got added, whether something got removed, and what are the nodes, exact nodes that got added into that particular DOM element and all that. And also we'll get mutation.target, which will give us the actual target that we're listening to, and other things like attribute names, old values, and all kinds of stuff. And this is how actually we use the mutation to actually observe those changes. So we have a target node, and if it is only a specific part of the page, it's going to only look for changes or mutations that happen within that part of the space. So it can be any DOM node that you want to listen to for mutations. It can be in the entire document.body, or it can be just a part of the document.body. So in this case, he's targeting some random element and then providing these options. These options can actually confine to the kind of changes that the mutation observer has to listen to, whether it's just the child list, or is it just the attributes, or is it just the subtree. Each of these can be independently turned on and off, and the observer will react only to those options which are turned on in this options object. So the observer takes two things. One is the target node and observer options. And then the observer itself is the result or the return value of the constructor call to which we pass the callback that we saw earlier. So this is how the mutation observer works. We'll now see how we can make use of this in a simple scenario. Here I am in a simple Codepen document, and then the HTML, CSS, and JavaScript is pre-written for us to save some time. Essentially, what's going on here is there is a input field, there is a button called add, and there is a div with ID messages, and the input field ID is source. So I'll come to the CSS part, but in the JavaScript, what we're doing here is we're taking the source, the button, and the messages, and then we are adding on-click listener to the button, which will check whether the source has any value, and if it has, it'll simply create a new paragraph and then add that data to the inner HTML of that paragraph and append that paragraph to the messages div. This is all that happens. Let's quickly check that. Test, added, test2, added. So this is what is happening essentially. Now, in this situation, we know that these DOM manipulations are happening in the on-click listener of that button. So let's say this is a frozen code base which is not accessible for modifications. But I want this paragraph to have a class. Okay, the class name is red border, and it gives border and padding to that paragraph. So I want to listen to changes to this messages div, because that is where the paragraph is getting added over here to the messages. It's getting appended right on line number 11. I want the paragraph to also have the red border class. So this is my specific scenario, and when those kinds of DOM manipulations that are required on the fly, and you don't have access to that particular API to actually modify, and you don't want to listen to some random DOM manipulations, right? So it can happen anywhere in the page. So I want to create a mutation observer and attach to the messages div, and let it take care of all the changes that I want to do. That is what a mutation observer is useful for, and it can be resource, low resource, consuming method using which you can achieve quicker results like this. Now let's see how this can be done. As we saw earlier, we have to create a mutation observer. So I'm going to do observer equals to new mutation observer. This is readily available for us because this is part of the DOM APIs. So it is part of the global object. Now I'll simply say, I have passed a callback function here. As you can see, this is the callback function that I passed. It can be written somewhere else, but I'm putting that in line to save us some space. And this DOM will take this callback will take two things, but we are only concerned about the mutated list. So I'll say mutation list. This one is actually the array of nodes or targets that got changed, right? So I simply iterate through it. I'll say mutation dot for each, and then this will take a callback. This is a simple for each, and each mutation will be coming over here, and then I'm going to so this mutation object, like we said, has the target, and then I'll simply try to find the list of paragraphs added to that target. So by taking the target equals to mutation.target, and then I'm going to find out the paragraph elements in the target. So I'm going to say target.query selector all, of paragraphs because I know that these are the ones that I want to target, and it'll give a list, and then I'm going to simply for each inside that list, and I'm going to get the para out of each of that list items, and then I'm going to simply find if that paragraph has the class, right? So if para, if it does not have a para a red border class, I want to add it, right? So I'm going to say class list dot contains red border. So if the excuse me, if the paragraph does not contain the red border, I want to say para dot class list toggle. This is all that is required, right? So what's happening here is that I'm taking the mutation, and the mutation target will be the actual target that we're going to observe to, and then I'm going to get all the paragraphs inside that target, and then I'll check if it has a border, if it has a class that is named red border, and if it doesn't have, I'll toggle that class so that it'll get that border. So now the mutation observer is ready to inject. So I'm going to simply take it and observe. And this will take two arguments. One is the target. We already have the target here, which is the messages. So I'm going to simply copy that DOM node, and then I'm going to give some options. I'm going to only observe child list because that is what I care for. We can leave the rest, or we can simply say attributes false, subtree false. So I know that I'm only observing the child list changes and not attribute changes and not subtree changes. All right, now let's see if this works. So I'm going to say test 1. Now you can see that the border is automatically added because the mutation observer now observes the changes to this particular div, and as soon as the paragraph is added by the button click, it comes here, checks that the paragraph that is added to that button, the div, does not have a red border, and it adds that red border class there. This is how the mutation observer is useful in situations where you don't have access to affect the API that is going on in the browser or in the web page, but you do want to listen to changes that are being done by that API and react to that changes. Probably in this example, I'm just adding a class, but it can be as complex as you want. It can be a series of business logics that you want to run, and based on those business logics, you want to make decisions to whether redirect the user to somewhere, or do some backend query and fetch some data and show to the user, or do some an overlay model to show the user, okay, some sort of advertisement or some sort of feedback form or something like that, which can be, so the possibilities are endless with the mutation observer. And also one last thing to show here is that the browser compatibility wise, this is looking pretty good. So all major browsers here are actually giving full support to the Mutation Observer API. So you're free to use it. There's no problem with any of these browsers.